Hello, this is Martin Brennand from Manager Systems, and today we're going to be looking at how to use the camera solver inside Mocha Pro to export data out to Maxon's Cinema 4D. Okay, so here we are inside Mocha Pro, and you can see I've already got a scene set up. I've rotated out this guy in the foreground so that he doesn't block off my wall tracks, and I've tracked through a left wall over here, and we can see that surface clinging to the wall. And I've also tracked the right wall over here to capture the motion of that side. Now, when you're using the camera solver, you need to set up your scene in one of two ways. In this particular case, because we've got a moving camera, I need to track at least two planes that are not on the same plane. The fancy way of saying that is two non-coplanar planes, but let's just say two different planes. So I've got one over here just tracked around this vent with a nice simple perspective track, and the same on this side. I've just tracked that section, just doing a simple perspective track as well. So when you've got a moving camera, you need at least two planes, sometimes more if you've got a difficult shot. In this case, we've got a nice easy move through this alley here, so I'm only needing to do two. If it was going on further, I might want to start tracking the ground as well, but in this case, we've got nice, easy tracks on both walls. Now, if we only had a pan-tilt-zoom shot, in that case, where a camera is locked to a tripod or some other standing area and it only has pan, tilt and zoom in the shot, you only actually need to track one layer. This is because there is no parallax in a pan, tilt, zoom shot. With any other type of moving shot, you either have what's called large parallax, where the foreground is moving quite quickly compared to the background, or small parallax, where there's very little motion happening between the foreground and the background. So in this particular case, we do have a lot of motion, so I'm going to choose large parallax in this instance, and it means that I need at least two layers. So once we have our two layers, we can then go ahead and start working on the camera solve. So I'm going to turn off the roto in this instance because the roto was simply to block out some shapes, so I'm going to just turn off that roto, and I'm just going to minimize my group here. And I'm going to select both my left wall, and I'm going to shift and select my right wall, so I've got both selected, and we can still see the surface there for both those shapes. And then we can come down to our camera solve. So the camera solve module is a fairly simple process. Once we have our layers selected, we can choose from a number of options in the camera selection, and then we get it to solve. So we start out by default by having auto, and auto basically does a guess. It will guess whether it's a pan-tilt-zoom shot or a parallax shot, and then we'll try and guess for a number of focal lengths to determine what the camera is. If we already know what the camera is, and in this case we do, we can select the drop down and go and choose the option. So we have pan-tilt-zoom for those pan-tilt-zoom shots, the small parallax for when there's a small amount of motion between the foreground and background, and the large parallax shot, which is what we have in this instance. So I'm going to select that one. Now, once we select a camera, we get the focal length to come up. Now, I know this was shot on about a 35 to 70mm lens, so I'm going to keep it at that. If you're unsure, it's actually fine to just check all of them and let Mocha do the rest of the work. It'll just take a little bit longer for it to work out what exactly it is. And in this case, there's a little bit of zooming, so I'm going to turn on that as well. So once we've got our settings checked, we can go ahead and just click the Solve button. Okay, so I just sped up the footage there for a second so you didn't have to sit through the solve. Normally a solve like this will take between 10 to 20 seconds on a simple shot, and if you've got a more complex shot with more layers or much longer sequences, it will take quite a bit longer, but in this case it was a nice simple shot, so the solve was pretty quick. And once we've got that solve, we do get a solve quality. And here we can see it's 94%. And this is a pretty good solve percentage. If you start getting below 80%, you might want to look to see whether your tracks are accurate enough. If there's any track drift, you can get worse solves. And you also want to check the size of your surfaces. If I just select the left wall for a second, we can see this surface is quite large in the screen. If I actually shrunk this surface down by just adjusting the corners, we'll actually get probably a slightly more accurate solve. And the reason for this is that we project this surface into 3D space, and the larger the surface is in the screen, the more Mocha has to work out the projection. So a smaller surface can actually mean sometimes a better solve. So in this instance, we don't need to worry about that, so I'm just going to now export out the camera data. So to do that, we just click the Export Camera Data button. So this brings up our camera data dialog, and we've got 4 options inside the dialog here. We've got After Effects motion data, FBX 6.1 data, FBX 6.1 data for Nuke, and hit film composite shot data as well. In this instance, we're going to choose FBX 6.1 3D data because that's the one we want to import into Cinema 4D. So we can go ahead and save that, and then it will save out a file. Now I've already done that, so I'm not going to bother in this instance, so I'm just going to click Cancel, and we can go across to Cinema 4D now and import the data. Okay, so here we are inside Cinema 4D, and we want to bring in that FBX file. So I'm just going to come up to File, and we can choose either to merge the FBX file, or choose Open. In this case, I want to choose Open because I want it to match all of the settings from Mocha. So I'm just going to click Open, choose that FBX file we exported from Mocha, and click Open. So this brings up the FBX import settings, and we can leave all of these as default. So I'm going to click OK, and the same goes for the take. Just make sure Mocha Animations is selected, and click OK. And this brings in our camera and the nulls based off the surfaces in the Mocha scene. So if we scrub the timeline here, we can see how that camera walks through the shot, and if we select the left wall nulls, we can see that there is 1 null for each corner of the surface that we made in Mocha, and 1 for the center. And the same goes for the right wall. If we select all 5 of those nulls, we can see there's the 4 corners and a center null. So to see that a little bit better, let's set up the actual scene. So to see these projected correctly in space, what we want to do is make a background and then apply the footage we tracked in Mocha to that background plate. So let's do that first. So I'm going to come up to Create, Environment, and choose Background. And this creates our background object. You can also get to background by choosing the Environment button up here and selecting background from here. So once we have our background, we want to apply the footage we tracked to that background plate. So to do that, we want to create a material. So I've got my material panel down here, so I'm just going to double click that, and that brings up our first material. And we just click on the texture empty button here, and that loads up our browser. So we just select 1 frame of the footage that we were working with, and open that up, and we can see that's now on our material. So once we've got our material created, we want to go back into the texture by clicking on that button again, and this loads up the bitmap shader, and we want to make sure that we select animation inside that shader, and then make sure that it's using the start and end frames. We can do this by clicking the calculate button, and so now we've got all the frames that were in that shot inside Mocha. Now check your frame rate as well, because you want to make sure that it matches what was inside Mocha. If the frame rates don't match, you may get some drift within your shot, so it's very important to make sure those frame rates and those start and end sequences actually do match. So once we have our animated texture set up, we just need to apply the material to the background. So we can simply do that by dragging the material up to the background object. And that immediately applies the material in the view, and you can see it here in the Cinema 4D viewer. Now at the moment it's sitting in the perspective view, so we want to look through our camera. So to do that, we just come up to our Mocha camera node and click the camera object viewer here. And this automatically animates the camera so that now we look through the camera that we have in our objects. So if I just go ahead and select my nulls now, and I drag the timeline, we can see how those nulls are now lining up with the view that we tracked inside Mocha. And we can start applying 3D models to this view quite easily because we now have everything locked down. So let's have a look at that now by just doing some basic positioning with a cube so you can see how to align that model. So I'm going to come out of my camera view for the moment because I just want to see perspective mode, and I'm just going to turn off the rendering for that background so that I can see my scene a little bit better. So what we want to do is create an object, and in this case I'm just going to use a cube. And we want to actually align it with one of these nulls. In this case I'm going to use the left wall. Now, when we actually calculate these nulls, they may not be exactly aligned to the wall, so you may need to adjust your 3D model once you've actually aligned it. So what we need to do for that is we select our cube, and we come up to Tools, Arrange Objects, and get the Transfer tool. And what the Transfer tool does is it takes whatever you've got currently selected and aligns it with whatever you highlight in the scene. So here, if I highlight, say, the top left corner, you can see how that line shows the transfer to the cube to this point. In this case, I'm going to use the middle point and just click that center null, and you'll see that cube jump immediately to that point. So if we come around, we can see how that's now sitting on top of those nulls. Now, the scale of this thing's pretty high at the moment, so I'm just going to create a slightly smaller shape. Let's make it about 10 by 10 by 10. And let's go into the view again to have a look. So I'll turn back on my background rendering. So we can see that's quite small in the scene, so I'm just going to make that a bit bigger. Let's make it, say, 100. And we'll make it 100 in X. So we can see here, if I scrub through the timeline, that it's slightly off angle because it hasn't aligned, the axis hasn't aligned perfectly when we've done the camera solve. So what we want to do is just choose our Rotate tool, and we can start aligning that to the scene a little bit better. So we'll come around here a little bit. So now when we scrub through the shot, we can actually see how that is aligning very, very nicely inside the shot, because we've first of all transferred the object to the null, and then we can rotate the object in space to actually sit it where we want it. So the same would go for the position. We could just move it up and down to where we want it. Say, for example, we were replacing this vent with, say, like an air conditioning box or something like that, or we wanted to insert some drain pipes. It would be easy to insert the models based on the position of the nulls within that scene. So that's how you calculate a camera solve inside Mocha Pro and bring it into Maxon Cinema 4D. If you'd like to learn more about the camera solve process, you can check out our tutorials at ImagineerSystems.com and go to the video section. If you've got any more questions, you can also go to the forum at forum.imagineersystems.com. This has been Martin Brennand for Imagineer Systems.